In cybersecurity and DevSecOps work, generating structured and readable reports is a critical skill. After scanning ports, extracting IP addresses from logs, or running an Nmap wrapper like you did in your mini project, the raw data collected must be transformed into exploitable reports. These reports are what you share with clients, team members, or store in databases for later analysis. Python offers three main formats for this: plain text, comma-separated values, CSV, and JavaScript Object Notation, JSON. Each format has its own use cases, advantages, and syntax, and Python provides built-in tools to handle all three. Before diving into each format, it is important to understand why reporting matters in security contexts. A penetration tester who discovers an open port, an unexpected service, or a vulnerable endpoint must document findings clearly. Reports serve as proof of work, enable reproduction of results, and guide remediation. The format you choose depends on the audience: plain text for human-readable summaries, CSV for spreadsheet analysis, and JSON for data exchange with other tools or systems. Plain text reports. Plain text is the simplest format. You write human-readable output directly to a file using Python's built-in file handling. This is appropriate for executive summaries, quick logs, or manual review documents. To write a plain text report in Python, you use the open function with the write mode W, which creates or overwrites the file, or A, which appends to an existing file. Always use a context manager with the with keyword to ensure the file is properly closed after writing, even if an error occurs. Example: results equals host 192.168.1.1 port 22 service SSH status open. Host 192.168.1.1 port 80 service HTTP status open. Host 192.168.1.1 port 443 service HTTPS status closed. With open report.txt W as file. File.write port scan report \n. File.write equals \n for result and results. Line equals f host, result host, port, result port, service, result service, status, result status, \n. File.writeLine. This produces a file called report.txt with a readable table-like structure. Notice the use of f-strings, formatted string literals, to embed variable values directly inside the string. The \n character adds a line break after each entry. For appending to an existing report without overwriting it, you replace W with A. This is useful when you want to accumulate scan results from multiple runs in a single log file. Plain text reports have no standard structure, which means they are flexible but not easy to parse programmatically. If another script needs to read and process your report, plain text is not the best choice. CSV reports. CSV stands for comma-separated values. It is a tabular format where each row represents a record and each column represents a field, separated by commas. CSV files can be opened directly in spreadsheet software like Microsoft Excel or LibreOffice Calc, making them ideal for reports that non-technical stakeholders need to review. Python's standard library includes the CSV module specifically for reading and writing CSV files. You do not need to install anything extra. To write a CSV file, you use csv.writer or csv.dictWriter. The dictWriter is particularly useful when your data is already stored as a list of dictionaries, which is a common situation after scanning operations. Example using csv.dictWriter. Import CSV. Results equals host 192.168.1.1 port 22 service SSH status open. Host 192.168.1.1 port 80 service HTTP status open. Host 192.168.1.1 port 443 service HTTPS status closed. Fields equals host, port, service, status. With openReport.csv, W, new line equals as file. Writer equals csv.dictWriter file, field names equals fields, writer.writeHeader, writer.writeRows results. The writeHeader method writes the column titles as the first row. The writeRows method writes all records at once. The new line equals parameter is important on Windows systems to prevent double line breaks. The resulting CSV file looks like this: host, port, service, status. 192.168.1.1, 22, SSH, open. 192.168.1.1, 80, HTTP, open. 192.168.1.1, 443, HTTPS, closed. To read a CSV file back into Python, you use csv.dictReader, which reads each row as a dictionary using the header row as keys. With openReport.csv, R, as file. Reader equals csv.dictReader file, for row in reader. Print row host, row port, row status. One important detail, CSV does not handle commas inside field values well by default. The CSV module handles this automatically by wrapping values containing commas in double quotes. Never manually write CSV files with string concatenation, as this leads to formatting errors for edge cases. CSV is a solid choice when your data is tabular, when you need to share results with non-developers, or when you want to import results into a database or spreadsheet later. JSON reports. JSON stands for JavaScript Object Notation. Despite its name, it is a language-agnostic format used universally for data exchange between systems, APIs, and tools. In cybersecurity, JSON is the standard format for tool interoperability. Many security tools, APIs, and dashboards consume or produce JSON. JSON supports nested structures, making it far more expressive than CSV. You can represent a host with multiple open ports, each with service details, all within a single structured object. Python's standard library includes the JSON module for reading and writing JSON. To write JSON, you use json.dump to write to a file, or json.dumps to get a JSON formatted string. Import JSON. Results equals scan_date, June 1, 2024. Target, 192.168.1.1. Open_ports. Port, 22, service, SSH, status, open. Port, 80, service, HTTP, status, open. Closed_ports. Port, 443, service, HTTPS, status, closed. With openReport.json, W, as file. JSON.dump results, file, indent equals 4. The indent equals 4 parameter makes the output human readable by adding indentation. Without it, the entire JSON structure is compressed on a single line, which is hard to read. The resulting file looks like scan_date, June 1, 2024. Target, 192.168.1.1. Open_ports. Port, 22. Service, SSH. Status, open. Port, 80. Service, HTTP. Status, open. Closed_ports. Port, 443. Service, HTTPS. Status, closed. To read a JSON file back into Python, you use json.load. With openReport.json, R, as file. Data equals json.load file, print data target, for port_info in data open_ports. Print port_info port, port_info service. This loads the JSON content back as a Python dictionary, which you can then manipulate freely. An important concept, json.dump writes to a file, while json.dumps, note the S for string, returns the JSON as a Python string. Similarly, json.load reads from a file, while json.loads parses a JSON string directly. Confusing these four methods is a very common beginner mistake. JSON handles special data types with some restrictions. Python dictionaries and lists map directly to JSON objects and arrays. Python strings map to JSON strings. Python integers and floats map to JSON numbers. Python booleans, true, false, map to JSON booleans, true, false. Python none maps to JSON null. However, Python objects that are not natively serializable, like datetime objects or custom class instances, will raise a type error unless you convert them to strings or numbers first. Example of handling a datetime. Import JSON. From datetime import datetime. Report equals scan_date, datetime.now, strophtime %y%m%d%h:%m:%s. Target, 10.0.0.1. With openReport.json, W, as file. json.dump report, file, indent equals 4. Here, the datetime is converted to a string using strophtime before being stored in the dictionary, which avoids the serialization error. Choosing the right format. Use plain text when The report is meant for direct human reading only. You need a simple activity log or summary with no further programmatic processing. The audience is non-technical. Use CSV when your data is tabular and fits naturally into rows and columns. You need to share results with analysts who use spreadsheets. You want to import data into a database or pivot table. Use JSON when your data is hierarchical or nested, for example, a host with multiple ports, each with attributes. You need to integrate your report with another tool, dashboard, or API. You want to reload the data later in Python or another language for further processing. In the context of your Nmap wrapper project, generating a JSON report from the scan results is the most appropriate choice because the structure is naturally hierarchical. One scan session contains multiple hosts, each with multiple ports, each with multiple attributes. A CSV would flatten this hierarchy and lose information, while plain text would make programmatic reuse difficult. Combining formats. In professional security automation, you often generate multiple report formats from the same data. For example, you might generate a JSON file for tool integration, a CSV file for the client's team, and a plain text summary for an email. This means you should structure your code so the data collection and the report generation are separate steps. Collect all results into a Python data structure, typically a list of dictionaries, then pass that structure to separate functions that each handle one output format. This approach respects the principle of separation of concerns. Your scanning logic does not need to know about report formatting, and your reporting functions do not need to know about scanning. Security considerations. When generating reports, be careful about the sensitivity of the data you write to disk. Port scan results, IP addresses, discovered services, and especially vulnerability details are sensitive. Apply appropriate file system permissions to report files. Do not hardcode file paths that expose reports in publicly accessible directories. When sharing reports, consider encrypting them or using secure transfer methods. Also, be careful when reading external JSON or CSV files. Never use eval to parse data. Always use the appropriate module methods, JSON.load, CSV.reader, which are safe and controlled. Summary of key functions. OpenFile.txt, W, opens a file for writing plain text. OpenFile.txt, A, opens a file for appending plain text. CSV.dictWriter file, field names equals, creates a CSV writer that maps dictionary keys to columns. Writer.writeHeader, writes the header row in a CSV file. Writer.writeRows list _of _dex, writes all data rows in a CSV file. CSV.dictReader file, reads a CSV file row by row as dictionaries. JSON.dumpData, file, indent equals 4, writes a Python object to a JSON file. JSON.dumpsData, indent equals 4, converts a Python object to a JSON formatted string. JSON.load file, reads a JSON file and returns a Python object. JSON.loads JSON_string, parses a JSON string and returns a Python object. Mastering these tools and choosing the right format for the right context is a foundational skill for any security automation engineer. You will use these techniques repeatedly as you build more complex tools throughout the rest of this course.